looking at a fairly warm winter this year. Limited snow, shaping up a lot like last year thanks to a weather pattern called La Nina. That, at least, is what our weather team here at WRAL tells me. Welcome to the Daily Download. I'm Travis Fain, and today we're going to dive in on how they know all that, the science of predicting the weather. I'm joined by Kat Campbell, a meteorologist here at WRAL. She's going to explain this stuff. We're going to get into it. Kat, welcome.
Thank you for having me. It's kind of like an onion. You've got all your layers to forecasting. You start day of, then you move to the weekly pattern, then you get into monthly patterns, seasonal patterns, and we use different tools for every single one of those different types of forecasts.
And I think we're going to talk mostly about the seasonal today. And I'm going to start by hitting you with a bunch of stuff at once, okay? So every year the rest of the weather team, you make some winter predictions. Last year, pretty accurate. This year, you're predicting above normal temperatures, 2 to 5 inches of snow. How do you reach these conclusions? What is La Nina? Why is that important? What drives year-to-year variations in seasonal weather?
So a lot of that comes down to La Nina, and that's a state of something we call ENSO. And it's really interesting. To figure this out, we actually look at the Pacific Ocean. And you may be confused, the Pacific Ocean, how on earth is that going to affect our weather here in North Carolina? And we look at the equatorial region. So you're looking at the central Pacific Ocean, but we can actually tell different types of weather patterns that shape up there based on these ocean and atmospheric patterns that develop and the monsoons that happen. And those all create different types of patterns for us. And what that typically leads to when you see below normal temperatures in the equatorial Pacific Ocean is milder temperatures for us here on the East Coast during the winter months. And that's pretty accurate. That's one of the best tools that we have. But we can see variations from year to year in La Nina patterns, and a lot of that has to do with the jet stream. And we look more in depth at jet stream patterns that could shape up for the month ahead, really a month out. So we've been looking at the La Nina pattern, jet stream patterns, and a lot of it comes down to climatology as well in our spreadsheets that we all love and appreciate in the Weather Center.
So you're looking at what patterns have existed in the past, and all right, well, when those patterns existed, this is what weather conditions were. So you're basically looking to the past to predict the future, right?
Absolutely. That's one of the best tools we have is looking back at history.
But it kind of seems like it all comes down to where air moves and how warm that is an awful lot. That just sounds like chaos you're trying to calculate.
It's all connected, though. I mean, the ocean is connected to the atmosphere in every way, shape, and form. So you can actually look at these air cycles that we have with the ocean connecting to the atmosphere, different layers of the atmosphere, and it really comes down to a lot of physics for us. And I won't go too much into that, but El Nino, La Nina is one of the best tools, hands down, that we have to predict winter. But a lot of it, you're right, comes down to just the fine line. And I mean, that line is ever so fine in North Carolina between the moisture and the cold air lining up. We're always right on that line. And
this is our third year, we think, going into a La Nina period. That happens sometimes, including, according to our team here, 1998 to 2001. In one of those winters, we had 20 inches of snow. I know y'all aren't predicting that this year, but what is the likelihood? Like, is there a percentage you can break down that we get something like that, like an outlier winter?
It's possible. It's certainly possible. And I can't give you a percentage that we would get 20 inches of snow. I can tell you that chance is very, very low. But I do think that is very fascinating. There are very few times in recorded history that we have had 3 La Nina years in a row or even more than that. And the fact that one of those segments of 3 La Nina years in a row encompassed the 2000 snowstorm, it could be positive for snow lovers. But things like that, the 2000 snow, really come down to a very small scale weather pattern. And I don't think that necessarily could be related all the way back to something as broad as a La Nina pattern. But you got to get everything to line up just right for that. And I'm hoping for something good. Maybe not 20 inches, but we want enough for the kids to be able to go sledding. And by the kids, I also absolutely mean myself.
One of the things I can kind of wrap my head around how you could figure out, well, we think this winter is going to be warmer than normal. Like you said, you look at the weather pattern, the way the air is moving, what the ocean's been doing. But how can you predict with any confidence how often a really cold night is going to line up with precipitation to make it snow? Help me get my brain around that.
Right. 3 months in a row, it's impossible to predict that. So, we're kind of going with averages here. The average snow is 6.8 inches. Of course, that varies from year to year.
For an entire winter.
For an entire winter. And winter, I should say this, winter has a different definition for meteorologists than it does the general public. But I actually love the way that we do it. We keep it so simple. 3 months per season, even months. It makes it so much easier for record keeping to just have even months and not switch it around. So winter is December, January, and February for us, and that's what we're forecasting for. The normal 6.8 inches. We had 2.7 inches of snow last year. So we did pretty good with that forecast last year that we had for near normal.
Of all the things you do here at WRAL, and obviously you're on TV multiple times a day talking about the weather, but is whether it's going to snow, is that the thing that sparks the most joy among viewers? I mean, is that the thing that people are most interested in?
Yes, and myself too. That's why I do what I do to this day. I was a kid growing up in Winston-Salem, North Carolina, and I loved the snow. And I would go visit my family members, my cousins in Michigan. We would build snowmen, have so much fun there. And I always wanted to know, why isn't it snowing here? And how come? I mean, to be honest with you, I'd watch the news, get so excited. My parents would tell me that we could see snow. And there were a lot of mornings when I woke up the next morning and there was nothing on the ground. And that letdown and that pure disappointment is why I do what I do today. I ask so many questions. So I love it. I totally relate with the viewers. And, we get all kinds of fascinating weather here in North Carolina. I mean, we really get it all. We get ice, we get snow, we get tornadoes, we get hurricanes. But snow is the one that, there's a little fun to it. There's really no fun to ice, hurricanes, tornadoes, anything like that. But snow, you can have fun with it. So I think it gets people excited, brings out a little bit of a kid in many of us.
Yeah, and I guess it's seeing water transform into something that you can play with, that you can play on. There's something wonderful about that. We're going to take a little break here. We're going to come back in a minute. We're going to keep talking, and I'm going to step back and we're going to broaden this out. We're going to talk a little bit more about the science of weather more broadly. Stay with us. Welcome back to the Daily Download. We're here with Kat Campbell, a meteorologist here at WRAL, and we're talking about the science of predicting the weather. Kat, so how much of this comes down to physics, which some of us may or may not have studied in school?
Absolutely a lot of it. I studied a lot of it in school, atmospheric physics, and it comes down to what we call quasi-geostrophic theory. And we had to derive the equation of momentum that we use, all kinds of derivations that we did in college at NC State. They certainly didn't teach us to be on television. I did that when I was doing my schooling, in internships and things like that. But it really comes down to a ton of physics. But if I want to put weather in the most simplistic way that is accurate, weather is simply the atmosphere just putting itself back into balance. The jet stream is like a wave. It's like a sound wave. Any kind of a wave that you can really think of in physics, it's all just balancing itself out. There are dips, there are peaks in those waves, and it's all got to try to balance itself out. And that's what's happening. When we have weather, you've got a dip in the jet stream, that's creating rain, and that is trying to get the jet stream back in balance.
And the jet stream, that runs up the Atlantic coast, or where does that?
Stream. So the jet stream happens high up in the atmosphere. So it's the upper level pattern that we have, and it flows from west to east, and it's what carries all the weather systems our direction.
All right. So hot air goes up, cold air goes down. The planet is spinning. Mm-hmm. Is it as simple as all that?
Not quite. Certainly a lot more complicated than that. And I think a lot of folks want to know, you have all of these physics equations. You know what's happening in the atmosphere. You can back it up with science and with data. So why can't you predict the future more accurately or farther out than you do now if you've got it all figured out in the physics? And really the answer to that is interesting. It comes down to two ways that we can improve weather forecasting in the future. One of those ways is that we simply need more sensors. We use airport sensors across the country. And, great. We've got a ton of those in the U.S. We've got a lot of airports, even smaller airports give us all that data. It goes into our weather models as well as weather balloons. But there's a limited government budget for weather balloons, and we don't have as many of those. They actually don't even launch those from Raleigh. So we just need more data points. And in the U.S., we have a lot, but that's not the same everywhere in the world. And of course, we have very, very few data points over the ocean, and a lot of weather systems develop over the ocean. So in order to get a more accurate end to the equation, and the equation is the weather model, and the end being the forecast for the future, you've got to put the right numbers in to get the right outcome. And we just don't have enough numbers going into these equations that are the weather models. And the other thing we've got to do is input that data faster, data assimilation. And there are some really amazing female scientists that are doing really, really impressive work right now on data assimilation and getting really, really fast data into the weather models for us.
Yeah, that makes sense. I guess it's one thing to have the data. It's another to kind of lasso it all together and make it tell you what you want to know.
Right, because these are supercomputers. One weather model that we show you on TV, I mean, it takes a lot of time to run and it takes a lot of infrastructure. So while it's actively running, you've got to be putting new information into that model.
I want to ask what may be a simple question,
Okay.
but I've always wondered, what is a cold front? How do they work? Because we constantly see the arrows pushing down, and it's going to do something. I don't understand it.
So a cold front can be a difference between cold and mild air, or just a temperature difference, but it's not always just that. A cold front can be basically a difference in air mass. So it's a difference in temperatures, or it's a difference in moisture for us. Dew points is what we would use to define the moisture there. So during the summer, we have a cold front coming, but it doesn't cool down here in July. But sometimes the cold front will bring less humid air. So it can also be, a difference in how much moisture or how dry the air is coming our way. But it moves typically from west to east, and we see a change behind it once it passes through.
And so let me ask about farmers' almanacs too, because it used to be we didn't have all these computers. Mm-hmm. How would people predict the weather back then, and how accurate were they as compared to today?
Good question. Farmer's Almanac, I think it's fun. I look at it often. My grandfather used to pull it out when I was a kid every year, and we would look over it. Like I said, I absolutely love the weather and snow, so I always wanted to know. And they use a lot of the same tools that we use here, honestly, at least in farmers' almanacs in my lifetime. I cannot speak, if you go back to the 1970s, what they were using, but I'm sure it's a lot of the climatological patterns and looking back to make their forecast. But there's all kinds of fun tools, the woolly worm and things like that people use. So I'm sure, sometimes that works out. People use if it snows, if it thunders, then it could snow in 10 days theory. That is less than 20% accurate.
Yeah, that doesn't sound right to my ears.
It often means that you've got a strong cold front or something coming through. So I understand where it comes from, but it's not, 20% accuracy isn't top tier.
No, that's not great. That's not. So last year we had a warmer than normal winter. We think that's going to happen again this year. But I'm looking at the records, and it got down to 15 degrees on January 30th this past winter. Any idea where's the bottom this year? Can that be predicted at all? I'm putting you on the spot here.
All right. Teens, definitely teens. I mean, it's nothing abnormal to see teens. When we get into the single digits, especially over the past 5 to 10 years, it's becoming increasingly less likely that we see temperatures getting down into the single digits. But I think we'll easily be down into the teens this year.
All right. Kat Campbell, thank you so much for your time. We appreciate it. And thanks to you folks at home for listening to the Daily Download. If you'd like to hear more about things to do, whether the weather is good or bad, places to visit, restaurants you can enjoy in North Carolina, I want you to check out the WRAL Out and About podcast. That's a weekly podcast from WRAL News. You can find that in your podcast app. Search WRAL Out and About. Out and About, that is. Thank you for listening, and thank you, Kat.
Thank you.